Thank you, Matt. So hi, everyone. I'm Vaishali Nandal. I'm the engineering manager at Salesforce under the Diagnostics, Visibility, and Analytics Cloud. For the past year, we've been trying to do CI/CD for at least our services, and I'll be handing it over to Andrey Falko, who's our lead engineer and architect on the team. He's been with us for 7+ years, and he's now working on, architecting CI/CD for at least the DBA services on at Salesforce. All yours, Andrey.
Oh, 1 second.
Hi guys on the phone. If you guys have any questions, please feel free to post them on the chat.
So thank you, Matt, for the excellent introduction to Jenkins file. We're in the midway to converting to that, and we'll get to that in this talk. What we want to do in our talk is we want to tell you about our journey from getting Jenkins machines from out from under our desks and into Salesforce data centers. Salesforce data centers have a very high security bar, so we think there's a lot of value around that into how you secure your Jenkins machines to be pretty much, well, hopefully bulletproof. That's just a legal thing I have to do. I'm not going to read it. So first, we're going to tell you the background that motivated us to embark on the project. Then we're going to tell you how we went from having, handcrafted Jenkins jobs to something that's a little bit better than that. And then we're going to go through and show you what the details are inside of our phases of our pipelines. So imagine being a startup in 1999. There's no public cloud. All we had to do was deploy one app and get it successful. We had to also build it on top of our own data center because there was nothing better at the time. We quickly became successful, and what that success meant was that we had to shepherd customer data. For us, customer data is the crown jewels of our company. Airlines, hospitals, banks are our customers, and literally lives and livelihoods depend on us securing customer data. When you have customer data, there's multiple places where you have to secure it. The first place is you have to secure it from the external endpoints. You have to have your network security. You have to make sure your software doesn't have SQL injection attacks, cross-site scripting attacks. You have to secure at the perimeter. 50% of your attacks are going to come from the perimeter, but the other 50 are going to come in from your path to production. If you have a package store, for example, a Yum repository, you might have an attacker that's going to get in there and start shipping packages that have malicious things in that, and that's going to get to your crown jewels. Likewise, your thing that builds those packages, your Jenkins machines, those have to be secure as well. An attacker can get on them and circumvent what you're packaging into the packages that are going to go to your package stores. And finally, you want to prevent people from badge surfing into the office and shipping things directly into your version control and that rolling out to your finely tuned and secure infrastructure. Fast forward a decade to 2009, Salesforce at that point had 400 developers. That's the year that I joined. We had a very large app with a platform behind it. Continuous integration and continuous delivery at that point was actually fairly mature. We had compliance rules, what I'll refer to as the two-man rule in many places. So for example, if you submit something to version control, you have to have a code reviewer get that submitted to the production branch. Once you're ready, once your code is well tested, you have to have a release engineer promote it to production, promote the package to production. One of the reasons we were able to have CI/CD this early on was because we were a Java shop. We only had one build system to worry about. We only had one language to worry about. Things were pretty simple. Fast forward 5 years. In those 5 years, we had 25 acquisitions. We went from a single app and platform to countless apps and countless infrastructures. A lot of our acquisitions were using AWS. They weren't running in our data centers. Some of them had their own data centers. So things got a little bit complicated from our CI and CD standpoint. In 2014, we formed departments or clouds under infrastructure. We hired Randy Kern to shepherd that effort. And part of that effort was changing our infrastructure to roll out platforms, infrastructure platforms, kind of like what AWS has been doing for many years, but we needed it to work for things that roll out within our data centers. However, the state of our infrastructure was that it wasn't just Java apps. A lot of the platforms that we wanted to roll out, that we were rolling out, they were open source components. And that meant that we had to support multiple languages. There were multiple build tools. And the way we coped with that initially is by having pet Jenkins machines under our desks, enforcing our compliance rules, enforcing our two-man rules. And that quickly got really complicated. We formed a team to solve this, called the Strata team. The problem that we were solving was within the DVA, the Diagnostics, Visibility, and Analytics Cloud that was building monitoring platforms alone, and just in that cloud alone, we had 50 software packages that we were trying to ship to production, that we were shipping to production. We had 3 different Jenkins installations, each with different authentication mechanisms and authorization mechanisms. For one, I had to ask someone to add me to a list. For another, I had to log in with LDAP credentials. For another, there's yet something else. Everything was using freestyle jobs. So in order for me to find out how to build something, how to package it, I had to dive into these freestyle jobs and figure out how things were done. Some projects had pull requests enabled that made everyone happy for that project, but that was not consistent across the board. So what did we do? We took Jenkins, consolidated into one instance, and we took away administrative rights from people. We got that Jenkins into a secure environment, into our data centers, and we prevented everyone from creating freestyle jobs. At this time, we didn't have the current pipelines plugins that we have available. So to describe what we did, it's best to look at a demo. So if you don't log into the Jenkins instance, you can't do anything on it. You can just read jobs. Once you log in, you can kick off jobs. One of the jobs is a parameterized build job into which developers input information about their project. The project name, the email to send alerts to, the Git repo that the project comes from, the packaging type that you're using, the Docker test image to use, the unit test command that you run inside of that Docker image. We do the same thing for packaging. Integration testing, we have some support for that. The developer presses build, and the result is automatically generated pipelines that are all consistent, all following the same rubric, with pull request support enabled. The developers don't have to lift a finger if we want to roll any new features out to the pipelines. We recently onboarded everybody to the pipelines plugin that you can see here. Developers didn't have to lift a finger to get onto this new plugin. What the realization we came to was we don't want developers spending their time learning how to use Jenkins, learning how to configure DSL jobs or configure freestyle jobs. We feel that developers' time is best spent answering basic questions about their software. How do you unit test it? How do you package it? How do you run integration tests for your components? And then moving on to continuous delivery and deployment of your package, how do you define your application's health once it's out there in the wild? How does your application roll out? Is it stateful or stateless? Does it need orchestration to roll out? Where do you deploy your applications first? Where are your test environments? And how large is the footprint and where is that footprint? We wanted to build a one-stop shop for developers to both give answers to these questions, but also have answers to these questions for the specific components that they're interested in. On a high level, what you saw in the demo, we generated jobs that followed the following pipeline. The first thing that a developer does is create a pull request off of master into a Git branch. That pull request runs unit tests, creates a package, and then integration tests run off of the created package. Once your pull request pipeline passes, a code review happens where the code reviewer can click the button to get it pushed up into the master branch. And then we rinse and repeat until you're ready to promote to production. One of our two-man rules is that someone who did not write the code has to press a button to promote your packages to production.
You essentially repeat the same integration test for different stage before the code review and after code review, or you are running a larger set of integration tests after the code review.
Yeah, it's going to be the same exact integration test, and that's because we want to make sure that if somebody bypasses the code review, that we still have those same checks. But we'll have more details about the integration tests. Once your package is in production, next step is to get your stuff deployed into test environments or canary environments. Once those canary environments launch your new package, you need to have tests that feed back into a monitoring system that tell you how you're doing. By putting it in a monitoring system, you can make decisions on whether you need to roll back or not. And finally, the monitoring system feeds back into Jenkins. Now, you might have a question of why do we need this complexity? Why can't Jenkins directly trigger releases on the canaries? Why can't Jenkins directly run these production tests? And the reason that is we have security boundaries around where our deployments are. They're in completely separate data centers, and Jenkins is not allowed to see them because it's in a lower security zone. And we'll get more into that a little bit later, but we need to make sure that canaries never directly see Jenkins and vice versa. Once your test environments all pass, production tests pull out information from the monitoring system and they go through their deployments. And again, production tests feed back into the monitoring system. Jenkins reads that information and gives feedback to developers on how their change did through all of these environments. So now we want to dive into the details behind some of those phases that we introduced. The first phase is unit tests and static analysis. You saw in the demo that we allow users to input a Docker image and a unit test command. The main reason we did that, and Matt kind of introduced that in his talk, which is, as a Jenkins administrator, I don't want to deal with worrying about someone else's version of Maven, someone else's version of Golang. I want to completely, I want that to be the user's responsibility, the developer's responsibility to figure out what their build tools are. Because we were supporting so many languages and trying to support so many languages and build tools, it wasn't going to be feasible. People would be slowed down by a limited number of Jenkins administrators. So what we did was we run their Docker images, we control the Docker daemon, and run their unit test commands on those images. Because the unit test commands are freeform, we need to make sure that we run that Docker image on something that has the least amount of access to credentials or anything important on Jenkins. So you want to run it on a separate Jenkins agent and use the Jenkins credentials plugin. And of course, never give users access to the Docker daemon, because then they're going to do malicious things like mount slash and take over everything that you have. The packaging phase follows unit testing, and it follows the same exact rubric. The difference is the Jenkins administrator has to control the packaging formats. The reason for that is any package format that you add, you need to have signing for it. That signing needs to happen on separate physical machines where the signing keys are tightly controlled by the fewest amount of people. One of the things that we did was, for our RPM and tar package types, we provided a dual mode where users could produce RPMs, but also at the same time produce Docker images. And that provided us two things. First of all, we don't want to have to maintain multiple package formats. That makes things a lot more complicated for everyone involved. So we provided a future path for everyone to onboard onto one packaging format, hopefully Docker. And two, users took advantage of this to install RPMs onto their Docker images and use them for integration testing later on. It made a lot of legacy components more testable, because you didn't have to launch a VM somewhere and start yum installing RPMs. That would be already done for you by Docker files, pulling that inside of the pipelines. Once your software is packaged, you probably want to do some integration tests on what you just packaged. We believe that an integration test needs to operate on your packages that you're planning to ship. Your packages should be atomic things that you test. It's a little bit different than a Maven integration test, because a Maven integration test usually works off of a class path and then runs within that class path, whereas we wanted the final package to be tested. So what we did was we supported Docker Compose from the get-go. For those of you who don't know, a Docker Compose YAML looks like, one second. Whoops. There we go. A Docker Compose YAML defines how your components, which components you want to run, how they're run, and how they're linked together. The one requirement that we added was that users have to supply an integration test container. That integration test container itself is a Docker pipeline in our system. The only requirement that it has is that it needs to spit out a set of test results in JUnit format, and we volume mount it into the workspace. When that is in the workspace, Jenkins can pick those results up and tell you how those integration tests went. And you can see we link it to the things that we're testing. Integration tests comes with a lot of pitfalls. One of the pitfalls is that if there's a failure, you're going to have to figure out which component caused that failure. So what we do to overcome that pitfall is we change one component at a time in the pipelines. I don't know if any of you noticed, but we tagged this component to iTest ready. When the pipelines finish the packaging stage, they mark it iTest ready to indicate that the integration tests need to change it for this component in this component's pipeline. What that does is it ensures that if you see a failure, all the other components are unchanged. All the other components are on the latest tag, which we mark latest only after integration tests for those components themselves pass. So you know with a lot of certainty that it's your change to your component that probably caused your integration test failure. We also do a few sanitary things when we're dealing with these Docker Compose YAMLs. For example, we filter out all your port definitions, and we filter out any rogue volume mounts that a user submits. So anything that could be malicious, we have to filter out. Once your integration test passed, at that point, we need to deliver your package to production. Because we have those compliance rules, that two-man rule that I was mentioning before, a release engineer has to cause that to happen. We made it so that a release engineer has to only press a button to do that. Once they press the button, we can't, I mean, we wish we could push packages directly into production, but we can't. Jenkins doesn't have access to the production data centers. They have to flow into what we call a DMZ. And in our definition, a DMZ is an extra lockdown data center that has neither outbound nor inbound internet access. It's a lot tougher to get into, so we can put things into it like our master Docker registry in our notary server. So the packages are signed during packaging, and then they're promoted to the DMZ by the release engineers. Once it's in DMZ, production can pull those packages down and make them available to the servers in production. Those servers in production, of course, need to validate that package signing as an extra security measure. We faced a few pitfalls around the Docker ecosystem. One was that when you're dealing with Docker images, you need to control where the from tag is. If someone is accidentally pulling something from the internet, we need to make sure that that something doesn't have security vulnerabilities or is actually even approved from a licensing standpoint or other things. So we make the pipeline fail if we have something with from that's not compliant, that's not approved, that's not an image that we've built ourselves. The other problem is security updates to the base OS. In the RPM world or the DPKG world, whenever you have a kernel update, for example, you roll out that kernel package to all of the servers and you restart them. With Docker, because you're dealing with an atomic package that already contains those operating system binaries, you have to rebuild the whole image. So what we built to overcome that pitfall with Docker is we built a Docker file image update tool. What this Docker image update tool does is it scans our source code repositories for any invocations of from for the base OS or anything that depends on the base OS. And then we send pull requests to it. And I have a demo I can show you. So the topmost, let me play it. The topmost is our demonstration base OS. You can see that it's built from scratch. The one that invokes demo base OS is our base OS with JDK. And finally, we have a demo app that invokes the base OS with JDK. And what we're going to do is we're going to trigger a pretend update, a pretend security update to our demo base OS. Now this is all fast forward, so we don't have to wait 3 minutes for the base OS image to build. But once that pipeline succeeds, the demo base OS with JDK gets a pull request generated against it. If you go into the pull request, you'll notice that we've run a pull request pipeline against it. This base OS with JDK is itself a pipeline in our system, and we've changed the tag to the latest, to the last known tag that the CI system built. And then the process repeats. Once we merge that pull request, the process repeats with demo base OS with JDK. So it runs through its master pipeline run and generates a pull request to the demo app. Pull request runs for the demo app and tells you if your update is good, and then the version is updated for your dependent image or your parent image. What's important about this process is developers have the control over when to deploy their Docker images to production for those security patches. Furthermore, they get feedback on whether that security update could have broken what they built. Let me flip back. The next phase, once you're ready to deploy to production, the most vital thing that you can do for yourself is to monitor your system, to figure out what it means for your application that you're deploying to be healthy. The number one thing that we recommend is having a test running continuously that feeds back to a time series metrics database. That test ideally would be your integration test that you've invested your efforts in. If not, you should build some tests that kind of simulate a customer going through the motions of your system. Application metrics help you get better information about your system, about what you just deployed. And you want to make decisions off of what your monitoring system has collected. So let's fast forward to today. We have 150 pipelines on our system. There's about 50 pipeline runs per day. We have about 80 developers happily using the system. And our current challenges, things that we're working on today, is you probably noticed that there was no continuous deployment slide or continuous deployment slide. That's because that's something that we're working on right now. We're trying to get Jenkins to get the feedback from all of our production deployments. So that's up and coming for us. We want to build better Jenkins agent supports to continue to scale our system. And we want to pull out our pipeline declaration out from those parameterized build jobs and into version control. And that leads me to the next point, which is if we were to start this project all over again, the biggest recommendation we would make to anyone embarking on a similar journey is today there exists pipeline multi-branch and GitHub organization plugins. When we started, we didn't have this. We didn't have this luxury. And what these pipelines let you do is they let you have a Jenkins file under version control that will scan, the GitHub organization plugin will scan GitHub for your Jenkins files and launch all of your pipelines. One reason we haven't immediately uploaded to this, or we haven't onboarded onto these plugins just yet, is because by default, they allow users to have full use of the Jenkins file DSL. We don't want that level of control. We feel that will get us back to having freestyle jobs, and we'll lose the ability to roll out uniform changes and uniform features to users' pipelines. What we're working on is having what is called a strata file or something like that in everyone's Git repo that has all the high-level parameters, the high-level declarations that we built in our Docker file in our system today. And finally, the other piece of advice that we want to share is don't start your project by running on a single master. I was happy to see in Matt's demo that he was immediately using a Jenkins agent. We can't stress that enough. We didn't start with agents from day one, and when our pipelines became popular, our Jenkins became overloaded, and you know, it was kind of stressful to work through the process of getting over to agents. We want to continue, like this is our first engagement with CloudBees or with the Jenkins community, and we have a wish list that we hopefully want to contribute back, or unless someone beats us to it. The first feature that we'd love to have is user-controlled credentials that can be used by our integration tests. Right now, if we give users access to the credentials binding plugin in any way, shape, or form, they're able to update our administrative credentials. We don't want that risk to happen. We'd like users to have their own namespace where they can put their credentials without touching administrators or other users. And then the integration tests could take advantage of that. When you're building integration tests, a lot of times, actually forgot to go through some of the pitfalls, some of the other pitfalls. Integration tests can become really large. Like if you have an HBase system, you probably don't want to put that in your Docker Compose YAML. It will take a long time to launch that. You want to use an external HBase that someone has set up for you already, and that's where the credentials for integration tests come in handy. And the other thing on our wish list item is to make Jenkins agent support better. A lot of the plugins out of the box, they launch the slave.jar on the VMs themselves. But we'd like that to run in our agent container, where we've put in a few customizations that we don't want to lose, and we don't want to roll that out to our VMs. And then auto-scaling. We'd like to auto-scale VMs kind of like Swarm or the Dynaslave plugin from Netflix do. The issue there being that Swarm only works on containers, and that's not enough of a security barrier for us. We need to launch Docker containers on isolated VMs that we can destroy if they get compromised. So here's the takeaways from our talk. Limit access to your critical systems. Jenkins is a critical system if you're using it for continuous deployments or continuous delivery, or even CI validation for your compliance or PCI compliance or anything like that. It's a critical system. You have to secure it in that way. Freestyle jobs or freeform Jenkins files is a slippery slope, because your developers are going to have to spend time learning that syntax, and they're going to create pipelines that all look different from each other. Split your agents on security boundaries. I touched up a little bit on this on the packaging slide. You want your signing keys for your packages to be on separate physical machines where the keys are tightly controlled. It's all part of having the minimum amount of people having access to the minimal amount of things that they need. And finally, integrate Jenkins with your monitoring system. Get feedback out of your monitoring systems and communicate to your developers that they need to monitor their stuff. And that's the only way that Jenkins can give them feedback on how their deployments are going. I want to give some acknowledgments to the people who made this project happen and to make this talk as hopefully good as it is. Project contributors, Ian Varley, who helped with the talk, and then our security reviewer, who's been kicking our butt about making sure we kicking our butt with security requests. Thank you. Any questions?
For the Docker, first of all, great talk, thank you. For the Docker image updater, how do you identify the Git repositories that you want to scan, and how do you identify the Docker files that you want to update?
So we use GitHub internally. So whatever we have access through GitHub search APIs, it'll be able to find. So if the only thing it won't be able to find are private repos that don't have the user that's doing the lookups in their organization, in their GitHub organization.
Okay, so any org that user can see, essentially. Okay.
Yeah.
How about the identifying the Docker files you want to update?
Yeah, that's actually, so it does a reasonable job finding Docker files that have, the from tag. However, one interesting use case that was thrown at us at one point is someone wanted to use the Maven Spotify Docker plugin. So we would have to retrofit the tool to support something like that. But right now it only scans Docker files themselves using the from tag.
Is it by, so it's not by name, you actually look at the contents of the file to look for the...
That's okay. Right, yeah, and GitHub API kind of supports, makes that a little easier than it could have been.
I can ask another question, I had one. You had mentioned for signing that you wanted to sign this artifact on a different security boundary, maybe a different machine. Can you talk a little bit about how you actually move that artifact to a different area? Are you shipping it through Jenkins or some other means?
Yeah, I mean, it's Jenkins. Shipping the Jenkins workspace is what we recommend.
Salesforce has been around now for 18, 19, 20 years, whatever. If you had your druthers, and you can go back and say, make sure you don't do this, because in 20 years, this is going to come back and bite you in the butt. Your thoughts?
Yeah, I mean, it's kind of going back to the slide where we wound up having all these Jenkins pets under our desks. I'd say, try to work with security to get them locked down enough where you can get them into the data centers. I think that's the main thing I would say. And then, of course, don't try to get away from having to use freestyle jobs or freeform, like users doing their own freeform DSL. Try to converge on one way of doing things. The question is how many agents do we have? Yeah, we have a farm of maybe 100 VMs right now. No, they're an OpenStack. The question is how stable is our master and how many masters do we have? Well, right now it's kind of a passive active setup. So it's only one master. So it's been reasonably stable. I'd say we have maybe over the course of a year, 1 or 2 days of downtime. I would say that's mostly due to luck than anything that we did. There was one time where we did a scheduled, failover to the passive Jenkins to make sure that the backups work, and we're just moving it from a smaller box to a bigger box. The worst outage that we had was when, and actually the funny thing enough, it was before we had a passive master setup. One of our Docker builds caused a kernel panic, and that kernel panic caused the server to get into such a state where I had to get someone all the way in Chicago in the middle of the night to physically go in the data center and reboot the server to get it to come back up. That was the worst case that we've had. But again, yeah, we're kind of running more on luck with that passive master.
So I had a question about the future directions about CD, and so what's on your roadmap for integrating feedback back into Jenkins? Is that feedback going to come from production or canary environments? And are you going to be defining a standard way for applications to report if they're in a good state or not?
Well, we recently open sourced Argus, and that's what we're using as our metrics and visualization system. So we're working on integrating more with Argus, which has a lot of metrics about our application deployments in production. And so all the feedback, all the metrics that flow into Argus come from all of our data centers through a secure monitoring and metrics pipeline. And so Argus is kind of the central monitoring system that has all of the eyes into all of our data centers. So if we integrate Jenkins more with that, we can get almost all the feedback that we need into Jenkins, contingent, of course, on service owners defining the monitoring rules and deploying monitoring for their applications. Oh.
Yeah, to continue that thought, so if the deployment's going through Jenkins, do you have to tell Jenkins to do the rollback? How does that feedback work, right? Because do you have to abort the job, trap the SIG term, and then do something else?
Yeah, so Jenkins can't do it because it doesn't have any access. So it has to be something running within your data centers, probably your script or your Puppet manifest that does the deployment. That itself has to trigger off the monitoring system itself to determine whether it needs to roll back to a different version or not.
So you mentioned you have 100, 200 VM, as the build farm. So what's the utilization of that particular build farm?
Yeah, we get about 50 builds a day. So I'd say, at the worst case scenario, there might be 50 executors running across it.
Let me reframe the question. So you would not return the VM back to the basic infrastructure pool. You basically dedicate it. Basically you grab this 100 machine. Yeah.
Right. Yeah. We don't return it to the pool right now. We just have a pool and that's it.
All right. Thank you.
Oh, one.
I've been working on Jenkins within OpenShift, and OpenShift can manage some of these complexities that you were talking about. So is that a sane route that you would take, or you would not take that route? Because then you don't have to have somebody in Chicago wake up in the middle of the night.
I actually I don't know too much about OpenShift, so I'd love to hear your
Kubernetes, basically, essentially the same thing, Kubernetes.
Oh,
because
cool.
it will manage, if Jenkins goes down, it will bring up a new version, and then it will start your jobs automatically.
Yeah, that sounds, yeah, I'd love to learn more about that.
If you run only 50 builds a day, does that mean you don't run build for every submission as continuous, inauguration build process, or?
Yeah, I mean, I'd say we do run it for every submission. So yeah, it's basically 50 submissions per day that we're handling roughly.
Going once. All right. Well, if there are no more questions, thank you everyone for coming. I know it was a little bit of a drive for some of you, but hopefully this was of value. And we're more than happy to keep the conversation going. So if you have any further questions or anything, please feel free to reach out to Andrey or myself, and we'd be happy to answer those. Cool. Thank you, Andrey.